In this video, we'll learn about titrations and practice a problem involving a titration calculation. Titration is an analytical technique in which one can calculate the concentration of a solution. Typically, with a titration, a solution of a known concentration is put in a burette, and then an unknown concentration is in your flask. We often see titrations involving acid-base or occasionally an oxidation. With acid-base titrations, quite often the acid or the base is a known concentration and in the burette. And then the unknown concentration of the opposite is in your flask. In the flask, we have to have an indicator. Quite often, a common indicator that we use is called phenolphthalein. So if we do a titration set up like this, our known concentration will be our base, and then our unknown concentration is the acid. So when we start a titration, you'll read the top of the burette and you'll record how much of the solution you add until you get to your final reading. Remember, burettes read how much they dispense. And then the difference in the volume between your initial reading and your final reading, that's the volume of the known solution you used. So when we're looking at a titration, you have a starting point where we have a clear solution. So this means we have an acidic solution here. If you add a little bit of your base, you might see some pink forming. Then when you swirl the flask, the pink goes away. Once you add enough to where one drop will turn the entire solution pink and it stays pink, we know we've hit what we call the end point. This is when the moles of acid equals the moles of base. And that means we can use solution stoichiometry to determine the concentrations. If you end up with a really dark pink, that means you overshot it. And then you don't know the exact amount of volume you actually needed to hit that endpoint. When we do a titration calculation, you have a volume of your standard solution that's needed to reach the endpoint. That's the volume we read here. So this would be our volume of our known solution. We can use the concentration of it to convert to moles of that known solution. Once we know the moles of the known solution, we use the balance equation, convert to moles of the unknown solution. When we have the moles of unknown solution, we know the volume that we added to the flask. Since we measured out how much volume we put in the flask here, since we know this volume, we can determine the concentration because now we know the moles from the titration. Another way we can think about it is if we have, we'll figure out moles of A, use the balance equation, convert to moles of B, we can figure out the volume of B if we know the molarity. If we know the volume, then we can convert to molarity of B. Now, sometimes we might know what the mass of our substance is, and then we can convert to moles of substance. This could either be grams, or we can do or we might know the volume. So we might know the volume of A, and then we can convert it to moles of A by using the molarity. Hopefully this is review for you guys, where you can go between volume to moles, volume of A to moles of A to moles of B, or from grams of A to moles of A. All of this should be reviewed. You should be able to do all these calculations now. Let's practice this idea. If we wanted to standardize a solution of sulfuric acid, you're going to put 50 milliliters into a flask, add a few drops of indicator, and then have a 0.1524 molar solution of sodium hydroxide in the burette. Your burette reads 0.55 milliliters at the start and 33.85 milliliters at the end. What's the concentration of the sulfuric acid? When you look at this question, there's a lot to unpack. It may be easiest to kind of draw it out so we can see it visually. So what happened is inside our flask here, there's 50 milliliters of sulfuric acid. In the burette, we have sodium hydroxide. We know its concentration is 0.1524. It started reading at 0.55 milliliters. It finished reading, its final reading was at 33.87 milliliters. And our sulfuric acid is going to equal blank molarity. That's what we're trying to figure out. It's that step. First thing we want to do, write out the balanced equation. So in our balanced equation, we have sulfuric acid plus sodium hydroxide and that will give us sodium sulfate plus water. And to balance it, we need two sodium hydroxides, and we end up with 2 waters. Next thing we want to figure out is what's the volume of sodium hydroxide that we used. So our volume for our NaOH, that's going to equal our final volume, that 33.87 milliliters, minus our initial volume, the 0.55 milliliters. So when we do that, the volume of sodium hydroxide is going to be 33.32 milliliters. So now I have a volume of sodium hydroxide. I have a concentration of sodium hydroxide. I have a balanced equation, and I have a volume of sulfuric acid. I have everything I need to figure out what the molarity is. Now that we have all this information, we can set up our calculations. So we're going to start with our volume of sodium hydroxide, 0.03332 liters. And then I'm going to use my concentration of sodium hydroxide, 0.1524 moles for every 1 liter of sodium hydroxide. Then that cancels out the liters of sodium hydroxide. Then we get to use the coefficients from our balanced equation to convert between moles of sodium hydroxide to moles of sulfuric acid. So for every 1 mole of sulfuric acid, I end up with 2 moles of sodium hydroxide. So my moles of sodium hydroxide cancel. Now I have moles of sulfuric acid. All I have to do now is divide by the volume of sulfuric acid that I used, because remember, molarity is moles per liter. So I convert the 50 milliliters into liters. So I have 0.05000 liters. So that way, my units at the end are moles, moles on the top, and then everything else cancels except for the liters of sulfuric acid on the bottom. So that way I know my units have to be moles per liter. This gives us a concentration of sulfuric acid of 0.05078 moles per liter of sulfuric acid. This way, now I have my concentration of sulfuric acid that's in my flask here. It's 0.05078 moles per liter of sulfuric acid. So you can see when we do these calculations, once we know the volume of the known concentration, I just use the molarity of that known concentration to convert to moles. Then you have your balanced equation. Once you have your balanced equation, now make sure the moles of the substance you want is on the top. If the moles of the substance you want is not on the top, then you probably flip something over here. Once the moles of substance is on the top, then you divide by the volume of your unknown concentration. This gives you your units for concentration. And then doing a calculation should give you the correct answer. So this is how a typical titration problem is set up. You need to first have the balanced equation, figure out the volume of the known concentration from the burette readings. Remember, the volume is always going to be final reading minus initial. Doesn't matter if the initial is at 0 or at 0.55 milliliters like we have here. It's still always going to be final minus initial. And now you guys should be able to do your titration problems and do your titration calculations.